Okay, the question is on the YARS enzyme and delta Gs and amino acid substitutions. Pretty challenging problem, so let's take a look. What is YARS? It's an amino acyl tRNA synthetase, and the reaction is the enzyme plus ATP plus tyrosine gives you an enzyme tyrosine AMP complex plus inorganic pyrophosphate. So let's read the question. Histidine 45 is believed to stabilize the transition state of the YARS enzyme. According to the data, which of the following amino acids would serve as the most conservative substitution for histidine 45 in the mechanism of YARS? So what you're given is the formula, but they use delta delta G, not just delta G. It's kind of a tricky way of using delta delta G. Now, delta G of mutant minus delta G of wild type by definition equals delta delta G. It's in kilocalories per mole, as you might expect. They show you in panel B not only the histidine residue binding to the transition state, but also a plot of delta delta G on the y-axis plus the enzyme bound state on the x-axis. You're given 3 mutants for histidine. You have H45N, H45A, H45Q, and so you have to break out your knowledge of the one-letter amino acid codes. You get A for alanine, N for asparagine, and Q for glutamine. And you think about what those look like in your head, and you come over and recognize that if delta Gs that are less than 0 are the low energy stable form, then by definition, more positive delta delta Gs are more unstable substitutions and more unstable enzymes. And that's because if the delta G of the mutant minus delta G of the wild type is positive, then the mutant is more unstable than the wild type. So then what you were looking for then are the 2 extreme values, and what you see on the relevant portion of the graph, and that is the enzyme bound state, because you're looking at the transition state as dictated by the stem. What you see is that the H45N has the highest positive delta delta G, but the H45Q has the lowest, which means it's the most stable, and the stem asked you for the most conservative substitution. And the idea behind conservative means that if you replace the natural histidine, which would have a delta delta G of 0, what residue gives you something closest to 0? And that answer is going to be the H45Q, because it has the lowest delta delta G value. Over on the right side, what you see are some configurations for the amino acids binding to the transition state. You can see that in H45Q that the amide is optimally positioned to interact with the transition state, unlike the other ones, with the exception of histidine, the wild type. Although you don't have to understand the mechanism of how the amino acids and the substitutions affect the transition state, you should be able to deduce it from the actual graph itself. So this is a question on the chemical and physical foundations free test passage. We have a lot of really good stuff on the MCAT that goes for amino acids and free energy. Come check us out at medpathway.com.